Hey there, all the coding enthusiasts. Ever dreamed of creating a stunning physics particle collision effect using Python? Your dream is about to come true. In this captivating tutorial, we'll guide you through the process of building an inspiring visual display featuring particle collision and gravitational pull effect, as you can see in the background. This course is completely beginner friendly and it doesn't require you to have any prior coding information or knowledge. With this, I will be explaining each Python concept in detail. I will be explaining each line of code. So, are you ready to embark on a coding journey that fuses art and science? Let us deep dive into the full tutorial and unlock the secrets behind creating captivating particle collision effect in Python. Okay, so we'll start by importing the modules. Now, modules in Python are simple Python files which are created by programmers like you, which have different functions, classes, and variables, and we can use any functionalities directly by importing them. For this, we will be requiring four modules. The first one is Pygame. Now, Pygame is a very famous module. After this, we'll be requiring the system module. Now, this system module can be used to fetch date and time, and all of this system behavior. After this, we'll be using the random module. Now, random module is basically used to randomly generate values. After this, we'll be using the math module. Now, this math module will basically provide us functionalities, which are basically used in mathematics like formulas, finding square root and all of this. So it will basically make us, make the calculation hassle free for us. Okay, so let us run the code. Okay, so now our modules are imported. If you see any error, it might be because you are not having that particular module installed in your IDE. So for this, you can simply, follow up the documentation. You can simply pip install all the libraries. Okay, now let us move on with the code. So now what we'll be doing, we'll be basically initializing the Pygame. For this, we have to write pygame.init. Okay, now we have to call this function. After this, we have to run this code. Now, Pygame is also initialized. Now, the next thing will be to set the width and height of the boundaries. Okay, so it will be width and then it will be height. Now, what we are doing over here is very simple. The thing is that we are setting the boundaries. Okay, so what boundary are we setting? We are basically setting the display boundary upon which we will be showing, the particles. Okay, so the next thing will be to set the FPS. Now FPS I will be setting to 60. Now we have to also run this particular module. Okay, so now it is also done. So this block of code is also been executed. Okay, now the next thing will be to create our particle class. Now what is a class in Python? So in Python, class is nothing but a blueprint to a particular functionality. Okay, now using this blueprint, we can create multiple objects for that particular functionality. Let us suppose we have a class of, a car. Okay, and now using this class, we can create multiple cars. Right, now we can also have a blueprint of a house, and then we can create multiple similar houses using that particular blueprint. So here the blueprint is the class, and the houses, each houses basically represent the object of that class. Okay, now let us deep dive. So now we will be requiring a function over here, which is basically the initialization block. Now what is initialization block? So whenever you create an object of a class, you have to initialize some values. Okay, now these values can be different things. Let us suppose we have a class of car, and then we want to create different cars. Right, now there can be a car which can be two-seater, and then there can be a car which can be four-seater. So when we create this car, we basically pass that constants with this. So these constants are basically initialized using this init block. Okay, so here we'll be having few of the things. Like firstly, we will be having self over here. Now we'll be having x, then y, and then masses. Okay, now let us discuss what this self, x, y, and mass represent over here. So self is basically the context. Now in similar terms, we can simply say that self basically represent the object, or we can say the current object of this class. Okay, so this is basically instance of a class. Now similarly we are having three more parameters which are x, y and mass. So x and y basically represent the particle's position in a 2D plane, where x is basically the x dimension and y value will be for the y dimension. With this we are also having the mass. Now this mass will basically, it will be used to define the size, the speed and all of this for the particle. Now let us initialize these things. So we can simply say self dot x equals x. Okay. Now we will be saying self dot y equals y. Now what we are doing over here, we are basically specifying that this particular object is having this x coordinate, this y coordinate. So these parameters were received from where this particular object was created, and now we are initializing that values to this particular object. Okay, now we'll be having the radius over here. For this we can simply say self dot radius, and for this what we can say int. Now what we are doing, we are basically typecasting the value. So we'll be having a square root of mass, and then we can simply come over here and multiply the value with 2. Okay, now we are having the radius. So why we multiply it by 2? To increase the particle size. Okay, now we will be having self dot color. Now that color, color we basically do using RGB. Now RGB has three values: a value for red, a value for green, and a value for blue. Now we can, if we want to generate random colors for each of the particle, we can simply randomize this each individual value, and for this we can use the random module. We can simply say random dot rand int. Now this will simply generate a random integer. Now we have to provide the range. We'll be providing a range from 50 to 255. Now it is done for the first, which is red. Now we have to copy this out for the remaining. Like we have to do the same for green, and then we have to do the same for blue. So it is also done. Now the next thing will be to check for the mass. So we can simply say self dot mass equals mass. Okay, so now we have also initialized mass. Now the next thing will be to initialize speed. We can simply say self dot speed, and the simple formula of speed, but here we'll be using the random. So we'll be randomly assigning a speed for initial. So we can say uniform, and the values which will be, it will be from 0.1 to 1. So any value between this range will be picked. Now the next thing will be to provide an angle to this particular speed. Okay, so we'll be having self dot angle equals random, random dot uniform, as we have done for the earlier one, and then we'll be having 0,2 into 360. Okay, so it will be simply math dot pi. We can directly use that one also. Okay, so it will basically provide us the angle for a particular particle. Okay, so now we are done with the initialization part. Now the next thing will be to start building our project. Now what does particle mainly have? So particle will be having a movement, right? So let us define the movement of this particle. For this we can use another function. Now why we are creating all of these functions. So we are basically splitting the code into multiple functionalities, and if we require the same functionality again, we can simply call that function again. It is like you are moving your hand, so that is the functionality of your body. With this you are moving your legs, so that is also a functionality of your body, right? Now if you create these functions individually, and then you can simply recall that particular function, and then you can reuse that functionality again and again, and you don't have to write codes for each time. Okay, so each movement. Okay, now let us focus. So here it will be only one parameter, which will be the context self, which is basically the instance of the class. Now we'll be having self dot x, okay, plus equals self dot speed multiplied by math dot cos of self dot angle. So what we are doing, we are starting to move the particle. So firstly we have defined the movement in the xward direction. Now we'll be doing the same for y. For this we can simply copy out this code and we can simply paste it over here. Now we have to simply write self.y over here, and then we'll be also changing this value to sine. Okay, so now we are done. We are done with the movement, but there will be few more things which will be concerning, like when we have this particular boundary, this outer boundary of width 800 and height 600, we want that if a particular particle hits the boundary, then it should bounce back, right, or bounce off from the wall. So for this, what we can do, we can simply write the concept. We can simply say if self, okay, self dot x is less than equals 0, or self dot x greater than equals width. Okay, so we can simply say that you have to change the angle. For this, we can simply say self dot angle equals math dot pi minus self dot angle. So what we are doing, okay, so we are checking if the x value, it is less than or equivalent to 0, that means it has hidden the bottom part, or we can say the left part, and the width will basically, it is, we are checking whether it has hidden the right part. Okay, for any of this, we are just turning out the angle to the opposite side. Okay, now let us focus the same for the white one. So for this, we can simply copy it out. And you know how the y plane goes, right? So the y plane basically goes in, a vertical direction, while the x plane is in a horizontal. So for horizontal, we are considering width. So here it will be definitely height, right? So it will be height. Now the next thing will be to define this. So it will be self.y, self.y, and the remaining thing will be as it is. Okay, so we are done with the movement part. Now the next thing will be to define the gravity. For this, we can simply say def, and then we will be saying apply gravity. Now in this, what we have to say, we have to say self, comma, other. Okay, now here there are two contexts. Now the first one is basically the instance of this class, and the other will be instance of other class. So what are these two things telling us? So the self is telling us that we want to, focus on the current particle for this object, and the other is basically that we are focusing on the other particle. Okay, so we are basically focusing on two particle at the same time. Now what we will be doing, we'll be finding out the distance. For this, we can simply say other dot x minus self dot x. So what we are doing, we are basically finding out the distances in x and y coordinates. So it will be same, it will be other dot y minus self dot y. Okay, now we'll be finding out the Euclidean distance. For this, we can simply say distance equals, we will be saying max of math dot sqrt, which will be basically, we want to say square root. Then we have to say dx multiply 2, which is basically we are saying that we want to do dx to the power 2. Then we'll be saying, plus dy same to the power 2, and then what we'll be doing will be simply having a comma over here, and then there will be 1. So why we are keeping this 1 and why we are using this max? So we are doing this to avoid division by 0, so we want at least a value of 1. So now the next challenge for us will be to calculate the force. For this, we can simply say force equals, and then we can simply say self dot mass multiply by other dot mass, and it has to be divided by distance to the power 2. So for this, we can simply say multiply 2. Okay, so this is the simple formula. Now after this, what we'll be doing, we'll be basically calculating the few of the more things, which will be basically calculating the acceleration components. Okay, so for this, what we can simply say, ax equals force multiplied by dx divided by distance. Now the next thing will be to calculate, the ay axis acceleration component. For this we'll be having force, you know. Okay, so there is multiple spaces over here. We have to remove this. Now it will be force multiplied by Ty divided by distance. Okay, so we are done with this also. Now the next thing will be to basically update the particle velocity. We'll be saying update particle velocity. Okay, and what we will be doing, we'll be simply saying self dot speed plus equals ax divided by self dot mass. Now the next thing will be self dot angle equals math dot attend to self dot speed multiplied by math dot sine. Now sine of self dot angle. Now it will be basically plus y. It will be ay divided by self dot mass. Now you have to be serious while you are typing this because there can be, several mistakes. Okay, now it will be self dot speed multiplied by math dot cos of self dot angle. Okay, now here we will be having plus ax divided by self dot mass. Now after doing this, what we have to do, we have to simply click on this run button because we'll be checking if there is any error, because if we move on, there will be more functionalities and it will become harder for us to identify the errors. So we can simply click on this run button and we can see that we are having no errors over here. That means we are okay with our code till now. Okay, now let us focus on the remaining part. We can simply say over here and we can come over here and then we will be having the next functionality, which is checking for collision. Now what we can do for this is we can simply come over here and then we can say def check collision. Now this def keyword is basically used to define a function. Okay, so don't worry about this. Okay, now we'll be having two parameters over here, self and other, as we have discussed. The same for apply gravity. Okay, now what there will be, we'll be finding the same thing. We have to calculate the same thing again. Okay, so we'll be simply coming over here. The distance, the distance thing will change. Okay, so this two will be same. So we have to come over here. We have to paste this. Now the next thing will be to focus on the distance. For this we will be using distance equals math dot sqrt, and inside this we'll be simply having dx to the power 2 plus dy to the power 2. Okay, so we are having this. Now the next thing will be to check for collision, and then we can simply say if distance is less than self dot radius plus other dot radius. That means that both of them have collided. Okay, basically it will be checking that has both of them touched or not. So they have touched, right? If this condition is true. Now what we'll be saying will be merging the masses. We can simply say total mass equals self dot mass. So we'll be combining both of their masses, other dot mass. Now the next step will be to recalculate the the speed or movement towards the x plane. For this we can simply say self dot x self dot mass multiplied by self dot x plus other dot mass multiplied by other dot x. Okay, so we have done this, and then we'll be dividing it with total mass. Okay, so total mass, and we are done. Now we'll be doing the same for y. For this we can simply copy it out and then we can paste it over here, and then we'll be doing it for the y. plane, we'll be having self.y, self.y, and then we'll be having other.y. Okay. Okay, so we have done other.y. Now the next thing will be to recalculate the speed. For this, we can simply come over here and we can say, self dot speed, equals, we can say self dot speed multiplied by self dot mass, so we are saying simply self dot speed multiply self dot mass plus we'll be doing other dot speed, and multiplied by other dot mass. Okay, so we are also done with this. We have recalculated the speed. For this, we have to do one more thing. We have to divide it by the total mass. So for this, we can simply say total mass. Okay, now we are done. So we have calculated the speed again after the collision. Then we have to calculate the mass. For this, we can simply say self dot mass plus, plus equals other dot mass. Okay, so we are also done with this. So the next thing will be to calculate the radius again. So for this we can simply say radius. So radius equals init math dot sqrt, and then there will be self dot mass. Okay, so we are basically having the radius as int, so it will be basically a int value. Then it will be basically math.sqrt self.mass, and then we'll be multiplying it with 2 to increase the particle size. Okay, now the next thing will be to remove the other particle. For this we can simply say particle dot remove other. Okay, so we have also removed the other particle. Okay, so we are almost done. So we have till now done. What we have done is we have initialized the values for the particle, we have defined the movement, we have applied the gravity, we have also checked for the collision. Now there will be few more things which will be requiring. Let us focus on that particular parts. So the next thing will be to basically figure out how to create the particle. Okay, so let us create the particle, right? So we have done all the things, we have to just create the particle now. So what we can simply come over here and then we can simply say that we want to create the particle. For this we can simply come over here and we have to indent it properly, so it will be just in the function defining line. Okay, so here what we have to do, we have to simply write that okay, so let us focus. Okay, so it will be in the class line, okay, where we have created the class. So the indentation will be basically in the class line. So here the class was started, so we will be having the same thing over here. Okay, now we'll be having create particle. So for this we can simply say particles, we are saying particles equals particle, so it will be capital particle. Okay, so particle, then we have to pass the values. We can say random dot rand int with values 0, width, so we'll be passing the width. Okay, so we have passed the width. Now the next thing will be to randomly do the same thing for the y1. So we can say rand int, it will be 0, height. So what we are doing, we are basically sharing the position of x and y, and we are doing it randomly. Okay, so using the random. Okay, now the next thing will be basically to have the the next parameter, which was we can see over here. So the next thing which we were requiring is the mass. So we are doing the mass. For this we can simply come over here and then we can do the next thing. For this what we can do, we can simply say random, okay, dot uniform, and then what we'll be doing, we'll be saying 5, 20. Okay, and then what we will be having? We'll be having a for loop over here, which will be basically for dash in range. So it will be doing the same thing for 10 times. Okay. Now we can create more particles by simply copying it out, and then we can come over here, you know. Okay, so we have to come over here and we can paste this, and then we can increase it to 20 for the next time. Okay. Okay, so we have created the particles now. Now the next thing will be to focus on creating the Pygame window. For this, we can simply say screen equals, we can say Pygame dot display, and the next thing will be set underscore mode. We have to pass the width and height. We have done this. Now the next thing will be to focus on Pygame, okay, dot display. So we are basically setting the caption for the display. Set caption, and the caption will be particle simulation. Okay, so you can have any text over here, whichever you want. So the next thing will be to set the clock. We can simply say clock equals Pygame dot time dot dot clock. Okay, so we are having the clock over here. Okay, so we are done with the clock. Now, we have created the particle, we have created the Pygame display where we'll be showing. Now the next thing will be to create our main loop. For this, what we can simply say, we can simply come over here, and then we can simply say while true. So the first thing will be to handle the close events, or the quit event. For this, we can simply say event. So whenever user click on the window to close, we can simply say pygame dot event, okay, dot get. Okay, so we are getting the events. Okay, so it will be pygame only over here. Okay, now the next thing will be to come over in this loop, and we can simply say event dot if event dot type equals pygame, pygame dot, we can simply say quit. Okay, now the next thing will be to come over here, and we can simply say pygame dot quit, and then we can simply exit the system. For this, we can simply say system dot exit. Okay, so now we are done with this. Now the next thing will be to apply the gravitational interaction and all of this. For this, we can simply say that we can come down and we can have another for loop for this. So now what we are achieving, we are basically achieving the gravitational interaction. For this, we can simply say for particle in particles. So for particle in particles, what we are saying basically for other underscore particle in particles. Okay, we are saying if particle not equals other underscore particle, then we can simply say particle dot apply gravity. Okay, and then we can say other underscore particle. Okay, now the next thing will be to come over here, and we can simply say particle dot check collision. Okay, so we are simply saying check for the collision, and then we'll be saying other underscore particle. Okay, so we are done. Now the next thing will be to set the movement. For this, we can simply say for particle in particles. Okay, so we are saying for particle in particles, we are saying particle dot move. Okay, so we are simply saying particle dot move. Now the next thing will be to draw the particle. Okay, for this, we can simply say screen, so we have to fill the screen with black color, so we can see the particles clearly. 0, So it will be 0, 0, 0. So the color, the background color will be black. You can set the background color to white by simply changing the RGB value. You can change the value to anything for any color as per your wish. Now the next thing will be to have the for loop for particle. In particles, we can simply come over here and we can say pygame dot draw dot circle screen, comma particle dot color, comma int, so we are basically using the typecasting particle dot x. Okay, now here what we have to do, we have to come over here and then we'll be saying simple for int particle dot y. Then we have to come over here and we'll be simply saying particle dot radius. Okay, so what we have done, we have basically drawn the circle for the particle. Okay, so now the next thing will be to focus on the display flip. For this we can simply come over here in the for indent line and we can simply say pygame dot display dot flip. Okay, and the next thing will be to set the clock, so we can simply say clock dot ticks, fps. Okay, so we are done with the code. And okay, now let us check the code whether everything is right. So you can recheck the code and you can match it with me so you don't have any errors. So firstly we created the particle class, then we have initialized it, the object. For this we have simply used this init block. Okay, now the next thing what we have done, we have simply defined the movement function. Now this movement function will basically define the movement of the objects. Now after this we have this gravity which will define the gravity between two particular objects. Now we are having the check collision function over here which will basically check for the collision. Now after this we have created the particles, right? And after creating the particle we have created the pygame window. Now after this, here is our main loop which will basically check for any exit events or quit events. After that we are basically applying the gravitational interaction. After this we are defining the movement. Now we are basically drawing the particle, and finally we are flipping the display and checking for the clock. After this we can simply click on this run button, and upon this we can see this cool looking animation which we have achieved using this code. And you can see how these objects are basically merging with each other, or the particles are merging with each other. Okay, so this was all which we have to cover in this video. So for now what you can do, you can simply like the video, you can subscribe to our channel, you can share the video with your lovely ones. It will help us and it will also help you to stay updated with our latest update. Till then, have a great coding journey ahead.